Hi folks, I've been asked to do some work solutions for a couple of the types of problems that are on the second assessment task. This is the first one. It's the multiplying and dividing of a series of algebraic fractions. Now, the mathematics that underlies this question is as follows. Firstly, we'll recall that you can multiply together powers with the same base. So if I've got two powers, x cubed times x squared, we've got the same base as x. So to multiply them, you just add the indices. So in this case, it's x to the fifth. You can likewise divide powers with the same base. When you divide them, you subtract the indexes. 5 minus 2 is x cubed is the answer. The next bit of maths that underlies it is in a situation where we are dividing by a fraction, we think we don't actually divide by fractions. What we do is we multiply by the reciprocal. So you flip that around. So you multiply by y over x squared. Now, once you've done that and everything's a nice, neat fraction and multiplied together, you can then put all the terms together as you would normally. Another thing to know is that when you have algebraic fractions together, where you have something on the top, like x to the fifth here, and an x squared in the bottom, you can put them together exactly the way you did up here in this line here. So it doesn't matter where they are on the top and where they are in the bottom. If they've got the same base, you can put them together and apply the power rules. But it only works when your fractions are multiplied together. So that's the first thing we try to do. We try to just make it a series of fractions all multiplied together, and then we can put all parts together using the power rules. Now, going to this problem again, what we have here is the last bit here. As I said, we try to get it so that it's a series of fractions multiplied together. So the first thing we do is we take this last bit, which is divided by, and we invert that back fraction. So y to the fifth z goes to the numerator and the other bit goes to the denominator. Now that we've got it like that, what we'll do is to sort of make it simpler. Rather than trying to do it all in one line, I'll split it out into a series of lines where we can identify the thinking. First of all, I'll take all the numbers out. As you can see, the numbers at the front, you've got 2 and 9 on the top, and 12 and 8 on the bottom, and we'll put them together. Thinking about the letters now, when I'm putting the letters together, you can see that there's an X there, there's an X there, and there, and there. So I can apply the power rule to those. So the 2 on the top are just multiplied together, x to the fourth times x squared, so that gives us that part there, they're added. Divided by x, so there's that minus 1, and divided by another x there, so I have to subtract another one. So I've brought together all of the x's and applied the power rule for multiplication and added or subtracted the indexes depending on what they were. Likewise, you can do the exact same things for the y's and the z's. So the y will be y3 plus 1 minus 2 minus 3, and the z there will be 1 plus 1 minus 2 and minus 4. So putting it all together to make it simple, we now start cancelling out. 2 into 8 goes 4. 9 and 12 have 3 as a common term. 3 and 9 goes 3 and that. Then we put them together. So we end up, I made a quick mistake on the bottom. I've only left 1 4. That should be 16. Don't worry too much about that. And then we put together all the powers at the back. 4 plus 2 is 6. Minus 1 comes back to 4. 3 plus 1 is 4, and 5 and 9. Minus 3 into a 5 is y to the 4, and z is to the minus 5. Now, you could just leave it in that form if you wanted to, not a problem. If you particularly want to, you can go another step and put it all into a nice, neat fraction at the end, remembering that's supposed to be 16. The z to the 5 came on the bottom because up there it's z to the negative 5, which means it goes into the denominator. So you could just leave the answer as 3x to the 4, y to the 4th, all over 16z to the 5th. Can't go any further than that. And that's the way they work. One thing I'd recommend against for the exam is try not to go sort of from that line there right down into this sort of area all in one go, because when you try and put it all together in one step, it gets very difficult and easy to make a mistake. So I'd recommend showing something like this as an intermediate step to demonstrate that you've pulled everything together correctly using the power rules. Now, the second question that I was asked about is how to do simultaneous solution problems for these ones. Usually you'll get simultaneous solution problems of two straight lines, and that doesn't often go beyond that. The technique, though, is exactly the same. There's no difference. We know there are two techniques for solving simultaneous equations in two unknowns. There's substitution. Now, for substitution, what you're looking for, of course, is y equals or x equals. So if I have y equals something, whatever it's equal to, that's something, I can put it anywhere in any other equation where I see y. Likewise, if I have x equals something, some whatever on the right side, I can take that whatever and put anywhere I see x. So that's the idea behind substitution. The other technique we have is elimination, and we use that in situations where we don't have a nice simple equation like y equals or x equals, and we've got to be a bit more sophisticated about the way we do it. Now, in this case, what we notice is we've got y equals there and y equals there. So substitution is the obvious way to do it. Now, you've got two ways you can think of it. You can either go, both of them are equal to y. So what that means is the two back bits must be the same as well. Because if the left one has got y equals and the right one's got y equals, those two parts on the right must be the same. The other way to think of it, which gets you to the exact same point, is I'm going to use substitution, and I will substitute that there, because that's equal to y, I can substitute it in there for y, and you get exactly the same thing. Right, so now once you get to there, you've now got a single equation in x. So the thing is that this equation, though, when you do substitution, when they're just two linear equations, you end up with a single equation, one of the unknowns, but it's a linear equation. It's just got one x or one y in it. The problem you've got here, of course, is that you've got an x squared. So the process, though, is just a bit more sophisticated, because you think, I look at this, it's an equation in x squared, I can solve that because it's a quadratic. So what you would do is take the 2x plus 5, take it over there, and then to that line, and from that point on, you now have an equation in x squared, which is a quadratic. You can simplify it. So in this case, it'll be x squared minus 3x minus 4. And you can then factorize that. You'll get two answers out of it for x. You substitute both of those values of x back up. I would put it back into that one because it's the linear equation. Substitute the first value of x in there, and then work that out. Then substitute the second value of x in there, work that out, and you get two values. So what you get are 2 points of intersection. Now, I'll leave the rest of the question for you to work out, because you have to give a graphical representation to explain why you might get those 2 points. What I would say is, for a problem like this, we know that the equation on the right there, that one there, is a quadratic, which means it's either like that or like that, depending on the nature of the equation. That's a linear equation, so it's a straight line. I'll leave it to you to demonstrate why you can get two answers out of that. It is fairly obvious. What I would expect in the exam is a reasonable drawing of the sketching. I expect that to be a reasonable drawing of what it is. So I expect it to cross the intercepts on the x-axis in roughly the right place, the right y-intercept, turning point in roughly the right place. Don't just rough something up and do it that way. I expect a reasonable drawing. But that basically explains how to do those two problems. If you have any other problems, don't hesitate to give me a yell.